All right, so let me go back up to make sure I'm in the right place. Okay, so that was what we're going to do. All right, we'll talk about all these things as you see on the board. So let's talk about with identifying a linear function. Key with this is your goal whenever you see a linear function, 90% of the time, they want it in y equals mx plus b. And I need to make sure that you agree that if I write it as f of x, where do you see the f of x at?
The y.
Is it the same thing as the y? Yes, it is. So where you see right here where it says f of x is equal to ax plus b, these two functions or equations are the same thing. They're the same thing. What's the difference? We replace f of x with a y, and instead of calling it m, I called it a, instead of calling it an m here, we call it an a, or vice versa. So does it matter? No. Most of the time, we're going to reference it as y equals mx plus b. That's called slope-intercept form of a linear equation. It's called slope-intercept form of a linear equation. I will usually just say y equals mx plus b. So with that said, the next slide, we want to see if you remember what it is to be a linear equation. Now, I gave you 3 different things to classify it as linear. What did I say?
Variables has to be by itself. You have to be able to get it by itself. No exponents and no variables.
Okay, so let me repeat it just so everybody can hear what y'all just said.
No variables on the bottom, no exponents, and 1 variable by itself.
Okay, so that sounds right. Does that sound right? All right, so you can have no exponents, no variables on the bottom, and you have to be able to get 1 variable by itself. Got to be able to do that. If you can do that, then it's linear. So with the first one, could I get a letter by, well, first of all, are there any exponents?
No.
No, are there any letters on the bottom? No. Could I get S or T by itself if I want to? Yes, we could. So again, just to kind of revamp what we did, I think we did 0 equals 3t minus S. What letter did we choose to get by itself? S. So I added S to both sides, and that's not a good marker. So we added S to both sides, and we ended up with S equals 3t minus, not minus, but plus 5. All right, done. Is it linear?
Yes.
Is it in y equals mx plus b form? Yes, it is. Did we use x and y? No. Okay, all right, B. All right, are there any exponents? Is the variable by itself?
Yes.
Are there any variables on the bottom?
No.
Then guess what? It's linear. When you type this in Desmos, what will it look like? A straight line. So here's what this one is. Is it in y equals mx plus b form? Hold on before you say anything. Is it in this form? Well, here's the y, and here's the b. Where is my m and my x? Well, the x is here, but when there's no x, it's 0. Okay? So it's written in the right form. It's just there's no slope. No, excuse me, that is incorrect. There is a slope. What's the slope? 0. The slope is 0. That's a totally different conversation if I say there's no slope. The slope happens to be 0. Why did I not write it like this? Why did I not write y equals 0 times x plus 9?
That's 2.
Yeah, it wants you to simplify it. 0 times anything is 0, and 0 plus 9 is 9. So if you left it written like this, it would mark it wrong because it assumes you didn't simplify the equation. Okay, we're good? So that was linear. What about the last one?
Yes. No.
I heard yes and I heard
I
no.
got it about it, so no.
Okay, so are there any exponents?
No, but it's a bottom.
Can you give a variable by itself? Yes. Well, what happens when we get the variable by itself? So I'm going to choose to get y by itself. Divide both sides by x. The x cancels, so I end up with y equals 5 on x, and you have a variable on the bottom. It is no longer linear.
You can't have fractions and then
You can't have variables on the bottom.
a variable.
You can have a fraction. So let me ask you a question, a good question. What if I have 1/2 x plus 3?
Yeah, it is.
Yeah, it's okay to have fractions. You just can't have x's variables on the bottom. I don't want to say just x's because it could be a c or p or q or whatever letter on the bottom. All right, we're good? The third, so again, you can't have variables on the bottom, can't have exponents, and you must be able to get 1 variable by itself. Oh, y'all about the Escalade.
Yes.
Okay, all right, well, we're getting there. All righty, so finding X and Y intercepts. Here's what we did to find the X and Y intercepts. You're gonna be given an equation, and the goal is find where that line, that's an equation of a line. 4x minus 8y equals 16 is an equation of a linear function. It's a line. So I wanna know, where does that line touch the x-axis, and where does it touch the y-axis? Those are called your X and Y intercepts. So in here, where it says, what got replaced here? What was here? It was an X. So in order to find the y-intercept, what do we have to do? Replace X with a 0 and then get y by it. Okay, can you see what happened down here to get y by itself? Okay, what'd you do to both sides? Divide by -8? Okay, 16 divided by -8 is? Okay, all right. Over here, what did we do?
Replace y with 0.
We replaced the y with a 0 and solved and got x by itself. What did you divide both sides by?
4.
Okay, and 16 divided by 4 is? All right, now notice, this represents a point on the what axis? Right, y, and this represents a point on the x-axis, okay? Now, how did I know to put a 0 here? Because you plugged the 0 in for x. How did I know to put a 0 here? Because you plugged the 0 in for y. So just remember, you can turn these into points, and sometimes the homework will ask you for it in point, or it'll just ask you for the number. Just be prepared to do either. Alrighty, so here's where we stopped. I know we did all of this. You purchased a $60,000 Escalade, and you paid $16,500 in interest, and your monthly payments was $1,275 per month. All right, for how many months? 60 months. All right, so the question was, down here they gave us an equation that modeled this situation. So now with this situation, is it in y equals mx plus b form? Yes. Even though it's written slightly what? Slightly different. Okay. Is it still in mx plus? Yes, it is. They put the mx over here and the b over here. So where does it cross the y-axis? That equation that I have my cursor on. Where does this cross the y-axis at what number? Well, you got to be able to. All right, so let me ask you a question because you're asking me. I heard the answer. This is mx plus b. What's the slope? Negative 1275. What's the y-intercept?
765.
Okay, just making sure we're on the same page. So where does it touch the y-axis at? 76,500. We're good? So that's your what? Your y-intercept. Wherever it touches the y-axis is the y-intercept. So that's your y-intercept. And what's the rate of change?
1275.
Negative or positive?
Negative.
Negative, because you are paying it off. So you do want that number to be negative, don't you? Of course. All right, because otherwise if it was positive, you still add paying more money. All right, so here is the next slide. Again, we're just discussing this because I know we walked through. So notice how they found the x and y intercept. Did they do what we did on the previous slide?
Yes.
Yes, they made the y equal to and solved and got x by itself. And to find the y-intercept, they made the x equal to? Okay, questions? All righty, here we go. It's discussing the same situation. Y'all know when we ended up at the end of 60 months, what does that mean? We're done. You have paid it off. You have paid it off. So where you see x corresponding to 0 months, you just drove it off the lot. 60 months, you just paid it off. All righty. Let's see if there's anything else I wanted to say. When you created your x and y axis for this graph, what did your x axis have to be from what to what? 0 to 60 months. And what was your y axis going to be? 0 to, you could do 76,000, 80,000, whatever you were comfortable with for that one. So there's the graph. That's what we had. All right. So here is the next part. Now, I think I stopped right here. All right, so good. All right, so we're going to talk about the slope of a line. So you've got two different things to conversations here. One is we're going to talk about it from a rise over run perspective. And the other one, you're going to be given 2 points, and then we're going to calculate the slope. All righty, so let's do the first one. Here is, what if we want to calculate the slope by hand? You have 2 points, and anytime you need to calculate the slope by hand, you're going to need the formula. Did you remember the formula? You did. What is it? Y2 minus Y1 over X2 minus. Are you going to need that on the test? Yes. Yes, you are. Are you going to need to memorize it? Yes, you are. All right, so given this is my formula, I'm just going to plug numbers in. Can I just plug the numbers in? Does it matter how I label them, whether I call it X1, Y1 or X2, Y? Does it matter which one I pick as my X1, Y1? No. You can label them however you want. Just be consistent. So, and let's do it. We've got a marker here. So here, if this is -7, 3, and this is 5, -1. Alrighty, I can name this X1, Y1. Or I can name this one X1, Y1 and make this one X2, Y2. It does not matter. You are going to get the same answer, no matter which one you put in is X1, Y1. Alrighty? So as you can see, they labeled them like I labeled them. So let me make sure I wrote this right. Did I write everything up here right, y'all? Yes. Alright, so I'm going to put in Y2 minus Y1 and X2 minus 7. All right, so I just wrote it like they wrote it. Can we simplify it? Yes. Of course. How did they get -1/3? How did they simplify the fraction? Divide top and bottom by 4, and you end up with -1/3. Questions? So far, easy. So if you're given 2 points and they say find the slope, this is all we have to do, right? Done. And do you have to simplify the fractions? Yes, you do.
That's what rise over run is?
Well, yes, that is rise over run, but I need to show it to you from graph form. So when you get this answer, which is what they have right here, this is still considered rise over run, but I want to show it to you from a graph perspective because that's when you're going to use it. Alrighty, so here is what we want you to remember. If it's a up, I call this uphill and downhill, y'all. To me, this is uphill, and this down here is downhill. Now, you should always be looking at it from left to right. Don't look at it from over here and try to say, because if you look at it from over here, now that one looks like it's downhill. So always look at it from the left to right. So if you look at it from this side, the first one is going uphill, and the bottom one is going downhill. So if it's going uphill, guess what? The slope is positive. If it's going downhill, the slope is negative. Okay. Now here is the interesting part. This horizontal line and vertical line, the top one is a horizontal line, the slope happens to be 0. Now 0 and no slope are not the same thing. So if it says the slope is 0, you can't say, well, we don't have no slope because it's 0. No, the slope is 0. Okay? So let me ask you a question, and I know this may sound like, okay, I can relate this. Again, if somebody asks you for the balance in your account, and you say the balance is 0, is that the same saying you don't have no balance?
Yeah.
No.
If the balance is 0, does that mean you don't have no balance? You have no money, but do you have a balance in your account? Yeah, you got a balance is 0. So again, same thing here. You have a slope, it's 0, but it's still the slope. Just like your balance might be 0, but it's still a balance in your account. So this one, the second one that you see is the vertical line. Now that one has no slope. There is no slope whatsoever. It is totally undefined. So in the homework, it'll say no slope, or it'll say undefined, no solution. Those are your answers that you will get if they ask you to find the slope of any vertical line. Well, how would you find that if you had 2 points? How would you know if you had a vertical line or a horizontal line if you had 2 points? Okay, well, let's look at 2 points. Here we go. Here are 2 points. I've got 2, 3, and I've got 4, 3.
That's why those 3's on the other side.
Let's do the slope formula. So if we do the slope formula, what's going to go on top? 3 minus 3 over.
4 minus 2.
Okay, and what do you have on top up here?
0.
And what's 0 divided by 2? What kind of line are these 2 points gonna make? A horizontal line. Can you see it? Watch. All right, so here is 1, 2, 3, 1, 2, 3. There's my point. This is over 4, and that's 3. Can I connect the dots?
Yes.
And it creates a horizontal line. So there we go. So if I connect those dots, I get a horizontal line. So anytime both y values for the points are the same, you got a horizontal line. Well, guess what the opposite of that is?
X values.
If the x values happen to be the same,
Then it's not.
then it's a what kind of line?
It's undefined.
So again, if I try to use the same formula, what am I going to have on top? 7 minus 4 over 3 minus 3, which gives me, what's that?
Undefined.
Well, put it in your calculator so you can be sure. If you type 3 divided by 0 in your calculator, what did you get?
Math error.
It's undefined. That's what you're going to get in your calculator. If you put 3 divided by 0, it's going to be a math error, which means this does not exist. We good? Okay, so when you see points, if the 2 y values are the same, it's a horizontal line. If the 2 x values are the same, it's a vertical line. Okay, you ready? Guess what the equation is for this one is? Let me put that, where's my black? Guess what the equation is for these 2 points? This is my line. I'm just trying to make a black line so you can see. Guess what the equation is for the horizontal line? It's easy as what you actually see. Don't make it hard. Don't get deep on me, y'all. What line, what line got, what number got duplicated? Done. Okay? So anytime you're given a horizontal, and that should be on the 3, y'all. Don't ask me why I didn't put it on the 3. It should be on the 3. Okay, so wherever it crosses what line did it cross? What line did, what axis, let me rephrase it. What axis did it cross? Okay, so it crosses the y-axis where?
3.
Done, that's the equation, y equals 3. What axis does it cross, and where does it cross it at? That's the equation for every horizontal line. So if I drew one at 6, it would be y equals 6. If I drew one at a line across 7, it would be y equals 7. You got it? Well, guess what? Don't you think that same thing applies for the vertical line? Okay, well, here we go. Here's our graph of the vertical line. And I'm going to do 1, 2. What was the multiple? 3. There's my 3. Because remember, what numbers got duplicated?
3.
The x equals 3. So at 3, I'm going to draw what? A vertical line.
Duplicated line is always backwards.
So what axis does it cross? And what number got duplicated? Were they the x's?
Yes.
Yes. The x's got duplicated, so this is x equals. That's the equation of that vertical line.
So whatever x equals is like,
Whenever x is duplicated.
yeah.
So it's duplicated, it's going to be x equals whatever that number is. When the y is duplicated, it's going to be whatever that number is. We got it?
Yeah.
Okay? So either way, if I give you the ordered pairs, you should be able to create the equation. If I give you the actual line on the graph, you need to be able to create the equation. Same thing over here. If I give you the 2 ordered pairs, you can create the equation. Or if I give you the vertical line, you can still create the equation. You okay? Alrighty? Alrighty, so let's see. We already talked about it being in y equals mx plus b form. So I did say, let me make sure I did say, so this is the important equation when it comes to linear functions. This is called the slope-intercept equation. That's the slope-intercept form of a linear equation. Just in case you can see. Okay? All right. This is the important one for this section. I need you to know that's the equation that we're shooting for every single time we do something. Now, the m represents the slope. What do you say the b represents? The y what?
Intercept.
Okay, so remember, this is your slope all day, every day. Whatever that number is that sits right here is always going to be your slope. And whatever number sits here is always going to be your y-intercept, which means that's where it's going to touch the y-axis. Alrighty. Questions? Alrighty, so here we go. We want to find the slope and the y-intercept. You have two equations. A, y equals 7x minus 12. What's the slope?
7.
What's the y-intercept?
12. Negative 12.
You good? Well, that was easy. What if I don't write the equation in that form? What if I write it like it's in form B? You got to solve it and get what? Y by itself. Because you cannot say, oh, and it happens every single test. I will write an equation like that, and guess what they give me the answer is? Slope is what? 2. I'd be like, no. So you can't tell me the slope with it written like that. You have to get y by itself. You have to solve and get y by itself. Then you can tell me what the slope is. All right, so let's solve and get y by itself. How do we do that for that one?
Change the x is 0 and divide by 3.
All righty, I hear y'all talking. All right, so subtract 2x from
Both sides.
both sides. See, y'all sound like y'all already know how to do all this math.
Negative 3y. Negative 3y equals negative 2x plus 12.
Okay, which one do you want me to put first, the 12 or the negative 2x? Why do I want the negative 2x to go? Because I want it to end up in y equals mx plus b. So I'm going to put the negative 2x and it's a positive 12, so that's got to be a plus. I don't have y by itself yet. What do I do?
Divide negative 3.
Everything on both sides is just divided by negative 3, so y equals,
Positive 2 over 3x.
okay, so a negative divided by negative is a?
Positive.
Okay, so that's a positive 2/3 x. 12 divided by negative 3 is a? Now what's the slope?
2 over 3.
So you can see you couldn't say 2 for the first time when you saw it the first time. You couldn't say, oh, the slope is 2. You had to rewrite it in y equals mx plus b form in order for you to tell me what the slope was. All right, questions? You'll see it again. All righty, so if there are no questions with that one, let me see. So we worked it out, the same problem, that bottom part B. We just worked it out on the board. We got the same solution that they have. Alrighty, this part of the slide is just re-emphasizing that we did use this information from when we bought the Escalade. Is this the same type of y equals mx plus b? Yes. Alrighty, here's just a graph and the ordered pairs that they created from the Escalade purchase and how much money we still owe the bank. Remember, X was the number of what? Months, and Y was the what? Amount of what? The amount of money you still owe the bank after you made that payment. Okay, so amount owed after you made the payment. So as you can see, we just created an XY table from that information. Questions? All righty, here we go. Here are some things that I need to make sure you know mean the exact same thing. When you see rate of change, which is M, which is slope, which is marginal profit, which is marginal loss. Anytime you see these phrases in the homework, all of it means slope. You see marginal anything, it means slope. Some of it may say marginal revenue, marginal profit, marginal loss. All of that still means slope. Rate of change still means slope. Got it? I'm just saying it because you're going to see those different verbs, the verbiage for it differently in the homework. Alrighty, so, all right, back to real life. All right, let's see if we can apply what we use. Now, let's make sure we read and understand the conversation. Using data and projections from 1990 to 2050, the percent of Hispanics in the United States population can be modeled by h of x equals 0.224x plus 9.01, with x equal to the number of years after 1990. What is the slope of the graph of this function? Alrighty, do you understand the conversation? We're just trying to figure out what? We are trying to figure out what the slope is, but the conversation, are you okay with the conversation? We're just talking about different years. How many what? The percent of Hispanics in the United States. Give them this year, what's the percentage of Hispanics? That's all the conversation is about. So based upon that, can you tell me what the slope is?
0.224.
Is it written in y equals mx plus b
Yes.
form?
Yes.
What's the y? What's in the place of the y?
H.
H of x is in the place of the y. What's the slope again?
0.224.
0.224. What's the y-intercept? 9.01. Okay, so y'all good. That's all they asked you for with this. Y'all good. What? Wait. No. So if you're not good, what was it that wasn't cool with you on this slide? Or you just saying in general? Oh, okay. All right. So again, all we did was use a real life situation to go back and apply. Does this relate to y equals mx plus b? Is it an example of y equals mx plus b? Does it give you a conversation that can use y equals mx plus b? Yes. Okay? Questions?
If you wanted to plug that into desmos, you would just replace the H with the F,
Type it just like you see it.
just like that?
Just like that. Type in H parentheses X, type it exactly like you see it in Desmos. You should get the same graph. If you don't see anything in your window, what's wrong? You got to change your window. If you don't see anything in your window, your graph window has to be expanded or zoomed in or out or whatever you have to do. Questions? All right. Again, they're just explaining what we just said. So we figured it all out. You all know what the slope was. So does that mean that there is an increasing percentage of Hispanic population as the years go on? Yes. How did you know it was increasing? Okay, because it's positive. What was positive? The slope was positive and you saw the graph. Was that graph increasing? Yes. So if the slope is positive, then that says, yes, over the years, we're expecting the population to grow with Hispanics. Okay? Question. Alrighty, next slide. All right, here we go. Marginal revenue and marginal profit. What are we trying to talk about here if it says the word marginal? Slope. Okay, all right, let's see if we understand the conversation. A company produces and sells a smartphone with revenue given by the function you see, R of X. Why did they choose R? Revenue. So the revenue function is 89.50 times X in dollars. And the cost is given by C of X. Why did they choose C? Cost equals 54.36X plus 67.90 in dollars. Where X is the number of smartphones produced and sold. What is the marginal revenue for the smartphone? What is the marginal revenue for the smartphone? Okay, what y'all want? What you want to tell me? There's no work to be done. You just supposed to give me an answer.
67.90.
Okay, so let me ask you a question. There's a revenue equation. There is a cost equation. Which one does it want? It says, what is the marginal revenue? So which one of those equations do you want me to use? Aha. So here is the first equation was R of X is equal to 89.50 X. Is that in y equals mx plus b form?
Yes.
Okay, well, let's see. Y m x plus b. What's b?
0.
Thank you. B is 0. So what was the question again?
What is the margin?
What is the marginal revenue? Are we on the revenue equation? And what's marginal means what? Oh, so what's the marginal revenue? 89.50. That is the marginal revenue. So it says for each iPhone, smartphone that we sell or produce, how much money are we going to make? 89.50 per unit, per smartphone. That's how much revenue. Okay? You okay with that? So again, where it says, what does it mean? It just wants you to make sure you understand, yes, the slope is 89.50, but what does it mean in English? That's $89.50 in revenue for each smartphone. Okay? Does that make sense? All right, so that's what we said. Now, rate of change, where it says marginal revenue is the rate of change, is the slope. All three word phrases mean the same thing, guys, right? So it doesn't matter how I ask it, you got to know slope, rate of change, marginal mean the same thing. All right, here we go. Next slide. All righty. Let's see what the first part of the paragraph is the same. The last sentence in the first paragraph, what does it say? Find the profit function. Is there a difference between profit and revenue? What? Okay, so there is, but what happened to it? How do you get profit then? You gotta subtract what? All the money that you gonna pay your employees, you gotta pay the water bill, the light bill, the rent for the building, all your inventory. So all of that has to come out. And once you have paid all of your expenses, then you have profit. So that's why it says, hint, hint, remember, profit equals your revenue, how much money you made, minus all your expenses. Alrighty, so here is it rewritten in what form? What form is this called when you got the P of X and the R of X and C of X? What form is it called when you write them with the parentheses and those letters like that? Function form. So this is function notation. So P of X is a function, R of X is a function, and C of X is a function. So it wants me to find the profit function. Well, they ain't give me no profit function. What two functions did they give you? Revenue and cost. But guess what? Profit equals revenue minus cost. So I'm going to take those two functions and just subtract them. All right, so I wrote that one out a little bit different, so I'm going to change how I wrote that one on the board because I want you to see it clearly and just make sure you're okay with it. So here is my revenue minus my cost is going to equal my profit function. All right, what was the revenue function? What's the cost function? 54 point what?
36 plus 6790.
Okay, plus 6790. Now here's what I want you to see with that. Anytime you're subtracting functions, you have to have a subtract and parentheses around this part of the function. Why? Why do you have to have the parentheses here? Because you got to distribute the negative sign. So now, here's a step that's not on the board that you don't see on the whiteboard. I should have 89.50. Once I distribute the negative sign, that's going to be a minus 54.36x minus 6790. Now, can I add like terms?
Yes.
Okay, so for the first two combined like terms, 89.50 minus 54.36 happens to be 35.14x. What do I do with that minus 6790?
Just bring it
Just
down.
bring it down. All right. We did all of this work to just figure out what? The profit function. So P of X is equal to 35.14x minus 6790. So it said find the profit function. Did we find it? Yes, we did. There's my profit function. Is it in Y equals mx plus b form? Yes, it is. What's the slope?
35.
What's the rate of change?
35.
What's the marginal profit?
6790. No, 35.
I'm asking you the same question 3 different ways. Because that's what the homework will do. It'll ask you the same question 3 different ways just to make sure you know this the slope, this the rate of change, this the marginal profit. All 3 mean the same thing. We okay? Alrighty, here is the explanation for what we just said. We just talked about all of that. So we're good on that slide. Okay, so we have just finished 1.3. Jump over to the homework for me, please. I always want you to make sure you take a look at the homework quickly before we start 1.4 so I can make sure you're comfortable with what you see on 1.3. So jump over to the homework, please. Log into your My Math Lab and just kind of glance at them. I just want to see if you're comfortable with what you see. Did I send the sign-in sheet around? Who has it? Anybody not sign in? Okay, we'll pass it back front and then back up top. Alrighty, homework for, all right, 1.3. Let's just take a look at it. All right, there are 15 questions. I'm just going to kind of glance through them to see, okay, you know the answer to that one. Okay, you know how to do that one. Okay, it says use the intercepts to graph it. Do you know how to find the X and Y intercepts? Yep, so you can graph that one. What happens, guys, I need to ask you a question about the X and Y intercepts. What happens if you go to find the x and y intercepts and one of them happen to be a fraction, what you gonna do then? Oh, here's what I'm asking you. If you go do all the math and you find say x equals to 0, then set y equals to 0, and you get x equals 2 for the x-intercept, and you get y equal 2/3 for the y-intercept, and it said graph it on My Math Lab. Well, this one, it'll let you graph this one because it's an actual integer, it's a whole number. It will not let you graph that 2/3.
You have to put that in decimal form, don't you?
So, and it will not take it in decimal form either. So you're like, well, what am I supposed to do then? It wants you to pick another number and plug it in till you get a whole number. Well, you could use rise or run if they, so again, here's the good question, can you use rise or run? If you end up with something like this, I'm making this up, guys. You can't use rise or run with the whole thing because this is, because where are you gonna put your first point? On here, but you can't graph that. My Math Lab will not let you graph this. It'll let you graph it fine if it's just a 4, because you put your first point on 4, then we rise up 2 and over 3, which we haven't gotten to that part yet.
Can I get the,
It's okay. And so with that, yes, you could graph it, but what if it's a fraction? So you cannot graph this with your x and y intercepts if this is a fraction, and you cannot graph this one if this is a fraction. What you have to do is go plug in some numbers that let you come up with a whole number or an integer. So you'd have to take your equation and randomly start plugging in numbers till you get a whole number as the answer. So if you plug in 0, see if you get a whole number. Plug in 1, see if you get a whole number. Plug in 2, see if you get a whole number. Of course, you can go to Desmos and see where they actually give you whole numbers. Do you know what I mean when I say go to Desmos? I literally mean type the equation in Desmos and see if you see the points that actually come out to be whole numbers. So if we go type, let me see if was the previous one. Let me see what that previous one was.
I have a question.
Yes.
What you're saying with the decimals, are you saying that y cannot be a fraction, or you can't?
I'm saying when you actually do the y-intercept and slope and the x-intercept, when it says make y equal to 0, and plug in a 0 for x, make y equal and solve for y, plug in a 0 for y, solve for x, you're going to get 2 answers like these. These represent points. So if I were going to graph these 2 points, this point is going to be what? I plugged in a 0 for y. So that point is going to be that point. When I go to do this point, this is 0, 2/3. My Math Lab will let you graph this one because it literally means go over 2 and up 0, which is fine. This one says go over 0 and up 2/3. You can't go up 2/3. My Math Lab won't let you put a point in between. So if you have a graph and you're trying to put as 1, 2, 3, 4, 1, 2, 3, 4, and you need to put a point right there, My Math Lab will not let you put a point right there.
So basically, the y-intercept can never be a fraction.
Neither one of them can. Neither one of these can be a fraction. And what I mean when I say they'll turn out to be fractions, what I'm saying is you can't graph them like that. It's okay that they turn out to be fractions, you just can't graph it like that. I'm trying to see which one turns out to be something like that so I can see if that's 5/4, that's going to end up being one that's easy. Let me see what this one looks like. Okay, that one's going to be easy for you to graph. Okay.
A couple of them turn into like halves.
You got one?
What, in this,
Yeah, you got one that doesn't turn out easily. I want to see one that doesn't turn out so. Because I don't want one that comes out to be a whole number because you already know how to do that one. I was just trying to see if there's one in here
I
that.
don't think I had to grab no, I did it, I didn't have to grab, half numbers.
Okay, so yours didn't turn out with fractions, which is fine. Okay, so when I do this
You know, like
one,
everybody's homework assignments be different. I think everybody's homework assignments be different though.
they are. You don't all get the same thing. It's a similar type of problem, but they're different problems, yes. You got one. All right, let me have it.
y equals 5x plus 3.
Okay, let me see. And what does it ask you to do?
First it actually gives the slope, and then the y-intercept, and then wants you to graph it.
Okay, all right, so give it to me again. What was the equation?
Y equals 5x
But now this one turns out to be okay. You can graph this one pretty easily. Let me think. What does it want you to do again? Let me see if it.
First it asks for the slope, which is 5.
Okay, so slope is 5. All right, we agree.
And then it asks for the y-intercept, which is 3.
Okay, so the y-intercept is 3. All right, we're good.
And then we have to graph it.
Okay, so now here's where rise over run comes into play, guys. So let's talk about this one because you need to know how to do it using rise over run. So here's the graph on the board, and it wants you to graph this equation by hand. When I say by hand, it wants you to tell me where to put the points. Your first point is always going to go on the y-intercept. Okay? So this is your y-intercept, which we called it B, but it's your y-intercept. Put your first point on what axis? On 3, on what axis? On the what axis? On the y-axis, because it's called the y-intercept, so it better be on the y-axis. So I'm going to go 1, 2, 3, and put a point. We okay? All right, what's the slope? All righty. Turn it into a fraction. If it's not already a fraction, turn it into a fraction. So put a 1 underneath it. And we're going to use that to do what we call rise over run. So we're going to rise up how many? All right, and then we're going to run how many? 1. So this means go up 5 and to the right 1. So start on the point we already got. So I'm going to rise up 5. So I'm going to go 1, 2, 3, 4, 5, and run to the right. How many? 1. So I'm going to put a point right there. Now connect the dots and draw your line. So once you put the 2 points, my math lab will connect the dots and draw the line for you. You okay with that? One of your equations should look something like this. This is what I'm hoping to get to it. It might have it as, let's say, and this will be an X. It might be something like that. And it says now, once you graph that equation, but you can't you can't put a point at 1/4. You can, because my math lab won't let you do it. So if you get an equation that's like this, then the question is, how can I actually do this one so it works out okay? So if I say, well, the y-intercept happens to be -1/4, so I can't put that one in. I can't put -1/4 anywhere on the graph. When I say the y-intercept is -1/4, do you understand how I got that? Yeah, so it is -1/4. So the y-intercept is -1/4. Can I plot that? No. So you can't plot it, and now you have to figure out what other number can I plot then, since I can't plot that one. So it wants you to plug some numbers in till you get whole numbers. So I'm going to start plugging numbers in. So I said we're going to plug in a 0. Okay, plug in a 0. Well, 0 times 5/4 is?
0.
Well, that gives me a -1/4. Well, that didn't help me. What if I plug in a 1? Well, 1 times 5/4 is? 5/4. And what's 5/4 minus 1/4? Hold on, make sure we are on the same page. That's times 1. All right, so, wait, I didn't need that parentheses there. All right, 5/4 times 1 is 5/4. And 5/4 minus 1/4 is? 4/4, which equals? Aha, I plugged in a number, I got a number. So now you can plot that number. You see what I mean? So you got to plug numbers in until you get a whole number or an integer as your y value. Because it's not going to let you graph that one. So pick another number, plug it in until you get a whole number. If you get an x-intercept or a y-intercept that you can't use it because it's a fraction, you got to pick another number. And it's trial and error design. It just so happens I pick 1. You might pick 1 and yours don't work with 1. So then you got to try 2. And you keep trying numbers till you get the right combination of numbers. Okay, let me see what else is in this homework assignment. All right, that's okay. All right, we talked about horizontal and vertical lines, how you create them. All right, we're going to graph that one. Okay, find the slope. Okay, we're okay with that one. We're okay with that one. Yes. Which one?
Yeah.
That one?
No, yeah,
That one?
no, 37, sorry.
Previous one?
No, it's 1.3.37.
No, but I'm saying look up here and tell me what number it says right here. 10. Okay. All right, next one. All righty. Questions? Okay, the percentage of high school seniors, everybody has this type of problem. Your numbers might be different, your equation might be different. The percentage of high school seniors using marijuana daily can be related to X. And X is the number of years after 1990. Does that mean people wasn't on smoking marijuana before 1990? No. Okay, that ain't what it means. Okay, by the equation, you have the equation 28p minus 19x equals 28. Find the x-intercept. Find the intercept. Interpret. Okay, I was getting the intercept and interpret word mixed up. Okay, find and interpret the p-intercept and then graph it. Okay, alrighty. Now, do they always have to use x and y? No. What letters did we use for variables? X and p. Which one is input? X. Which one is output? P. So if I want to, I need you to find me the x-intercept, which we call input. Now I want the p-intercept, which is your y. But they didn't call it y, they called it p. So it's the p-intercept. So if you want the x-intercept, you got to plug in a 0 for, look up there in the case, they ain't use y, p. And if you want the p-intercept, you got to plug in a 0 for the x. Okay, questions, what are you thinking? Okay, what part? C? All right, did you get 2 points that you could grab? You go back at this fraction thing again. So here's the equation, guys. We're back at this part again. So now, when you plugged in and got your, I'm trying to make sure I write my P. When you plugged in, did you get, what was your x-intercept? Did you get an x-intercept and a p-intercept? What was it? Yeah, when you plugged in a 0 for x, what did you get for p? When you plugged, was that your x-intercept or your p-intercept? Which one was that one? Read me yours again. That's x. And then what was your p that you got when you plugged in a 0 for c? Okay, so yours was 2. Can you see if I plug in a 0 for my x, I'm going to end up with, what is that going to be, 1? If that's a 0, guys, that's going to disappear. And I end up with 28p equal 28, which is divide both sides by 28, and no p equal 1. Mine would be a 1. Yours is going to be something different. So right now, hers was p equals 2, and over here she got a fraction. We can't plot that. Can we plot this one?
Yes.
Okay. Okay, so this is 0, 2. Okay? I can't plot this one right here. So guess what I got to go do? Plug in some numbers till I get a whole number. And then you can plot the other numbers.
So plug in numbers what we originally put the 0.
Plug in numbers for x.
Yeah, where you ready?
Plug in numbers for x. So we're going to plug in numbers for x. So again, in my case, like I said here, this is a p minus 19x equal 28. So of course, you plug in a 1, see what that gets you. Plug in a 2, plug in a 3, plug in a what, until you see what it comes up with a whole number. Which one works? 1 works? So if we plug in 1,
I think, oh, no.
1 don't work?
Wait.
Here, we plug in a 1. Somebody do the math for me. What we get?
2 works for mine.
2 works?
For mine.
Well, yours 2 worked. Okay, got you. So once you get your other 1 for 2, what did you get the answer for 2 when you plugged in 2? What did you get?
It's going to be 1.
So now you got your 2 points, so now you can plot those 2. So guys, you understand when you get to this problem, you got to plug in x values till you get a whole number or integer. You okay with that one? I need you to think about it. What's wrong with this one? You understand the conversation, right? They gave you an equation to create a relationship between x is the what? What's x in this conversation? Y'all can't see it? I thought y'all eyes were better than mine. Okay, so x is the number of years when? After 1990. So they're saying there's a relationship between the years and high school seniors smoking marijuana. Okay? They're saying whatever year it is, maybe it went up. Maybe it didn't. We won't know till we see we plugged in some numbers. Can I go type this equation in decimals? The original equation. Yeah, so I can see what the graph looks like. Yeah, can I solve and get p by itself? Yeah. Okay, we can do a couple of things with that. we just want to know, can you graph it? All we need is the x-intercept and the p-intercept. Instead of calling it y, they call it p. The question is, what do you have? What other questions do you have now, looking at this one? What you thinking? Is there a relationship between the years and high school seniors smoking marijuana? Do you think they smoke more now than they did years ago? No. So that's the question. They're saying, hey, there's a relationship between years and it's more accessible now. Kids got access to stuff I ain't never had access to. I'm like, what in the world? So again, the question is there a relationship? Maybe it is. Again, we're just looking at the actual equation and seeing, can you create any line? Can you see if you can create a line from the equation that you have? My equation, let me see what my equation looked like in Desmos. I'm just gonna plug mine in just so I can see what my equation looks like. Alrighty, what was mine? 28p minus, sometimes if you run it,
You have to change it into y.
I'll find out in just a minute if it takes it. Sometimes Desmos only likes x's and y's. And I'm gonna find out in a second if it likes it. So again, it doesn't like my p. Notice it doesn't like my p. So I'm gonna make it a y. There it is. There's my equation. What's wrong with my line? I'm gonna change my home. There we go. Why am I moving my screen? Why am I moving it so that it's down right there? Why do I want to see this part of the graph? Why do I not care about this part of the graph? Okay, look at what's over here. Look at these numbers. Negative. Is there such thing as a negative percent?
No.
Is there such thing as negative years? No. So I only want to look at the positive part of the graph. So here I'm looking at from 0 to 20 years. And then percent. How high can percent be? It's only going to go up to 100, so I can change my y-axis to 100 because it can only go up to 100%. Well, there's the graph if I change it to 100%. All right, so this is 1 year after 1990 is 1991, 92, 93, 94, 95, 96. You okay? Year 2000. Where am I now? 2005. I can change this so that I can see more years. So is the number of students, high school students smoking marijuana on the decline or the increase? Okay. All righty. Questions? Now, it asks for the X and Y intercept, guys, which is one of the things we were trying to find. Let me make my screen bigger here. I was looking for the X and Y intercepts. Let's see, where was that's my x-intercept. Here's my y-intercept. Now, excuse me, I said it backwards. Here's my y-intercept. Here's my x-intercept. I cannot use this number. Why? It's a fraction or decimal. My math lab will not let me graph it, which is why I had to plug in a different number. So I got one of my numbers right here, one of my points, can't not do the other one. All righty, which is why you had to plug in some numbers.
So if they got that, so how do we get 0 for our y?
That was yeah, that was a different equation. So this was not ours. This was not ours. Yeah, that was a different equation. All righty, questions? All righty, so let me get back to, all right, let me see where I was. Where was I, guys? What number was that one? That was 10? All righty, so if that was, let's see what I'm just looking to see what they look like. All righty. Okay, let me say something about constant and identity functions because that wasn't on any of the PowerPoints. If all the y values are the same, it's considered a constant function. If all the y values are the same, it's considered a constant function. Well, if that's the case, what does the identity function look like? The identity function looks like they're the same. Here's the identity function. If you plug in a 1, you get a 1. Identity means that they're identical.
Oh, yeah.
So if you plug in a 2, you get a 2. You plug in a 3, you get a 3. Plug in a 4, you get a 4. That's the identity function. X's and Y are both the same. Whatever you plug in, you get the same number out. Alrighty, so that helps to answer that. Let me see what else is in here. Okay, let's see, slope. Okay, you know what to do with that one. Okay, that one same as giving the X and R instead of X and Y. Intercepts, it wants the X and R. Okay, slope. Look at this one for a second, guys. It asks you for find the marginal profit, which is the same thing as a rate of change, which is the same thing as a slope. Can you find that given the information that they give you?
Yes.
Yes. What you gonna do?
200 and, y2 minus y1.
Aha, you're gonna use the y2 minus y1 over x2 minus x1. How do you know you're gonna use that formula? You got 4 numbers, 2 sets of points. And it tells you x is the what?
Number of units sold.
The number of units sold is x, and p is your profit, which happens to be your y. So that says when you got 200 sold, what was the profit? And then if you got 275 that you sold, what was your profit? So you got an x comma y and another x2 comma y2. So they're expecting you to go ahead and do that. All righty. So with that said, that should be enough for you to finish up that one. All right. All righty. So let's go to 1.4. 1.4 it is. Here we are. Let's go all the way back to the beginning of 1.4. All right. Equations of lines. Again, what was the standard? What is the form that you're gonna most see for linear equations that's important for this particular section? The slope-intercept form, which is also called y equals mx plus b. So in this particular section, we want you to create the equation, given specific information. You are to create the equation. So you can create horizontal lines, vertical lines, uphill lines, downhill lines. We'll also talk about parallel and perpendicular lines. We'll do average rate of change for things that are not linear. So let's get to as much as we can. We'll do as much as we can and then we'll stop. All righty, so you know what that form is, right? Y equals mx plus b is slope-intercept form of a linear equation. So let's talk about topics of where this is related to real life. Let's make sure we understand the conversation. The plumber charges $65 for a service call plus $30 per hour for each hour spent on the repair. Did we do this before? We talked about something like this.
I think it was just an example that you gave.
It would, okay, an example. All right, good. So key is that, is the information, can it be written in y equals mx plus b form?
Yes.
Anytime you are charged or paying something per hour plus a flat fee, you can write it like this. Okay? So could you write it like this to get your car repaired? How?
You put the part as the part is the extra,
The part is the extra.
and amount of time is the index.
Okay, so these are my parts, and this is my labor cost.
Yeah.
Okay, all righty. So it might cost $75 per hour plus $200 for the parts.
Yes.
There you go. There you have same kind of topic right there. Anytime you pay for something by the hour, you can write it as a linear function. Alrighty. Same thing we did with the Escalade, right?
Yeah.
Okay. Alrighty. So now, here is a slightly different equation that I want you to, a formula that I want you to use to be able to create an equation. So now, in the previous slide, well, they gave you the M and the B. Then they give you the slope and the y-intercept. Look at this again. They gave you $30 per hour, which is your slope, and they gave you the flat fee, which is your flat service charge. If I give you the slope and I give you the y-intercept, you don't have no work to do but just to plug it in for M and B, right? Here's the next, what if I don't give you all the information just outright? Can you figure it out? Yes, but you need that formula to figure it out. That formula is called the point-slope formula because you need a point and the slope. To use this formula, you need a point and the slope. We're gonna plug the point in as x1, y1, and we're gonna plug in m, whatever number we need for the slope as m. All right, so let's do this one. All right, there are three types of situations where you're gonna use your point slope formula. Here is situation number one. There will be three different types of situations, so you'll want to make sure you know what the different situations are. All right, ready? Type 1, you will be given a slope and a point. This is called type 1 for writing an equation of a line. Alrighty. Type 1, you're going to be given a point and a slope. Okay? So here are your steps. Step 1, identify x1, y1, and m. What's m again? Slope. Okay. That's your step 1. You got to identify what it is. Once you identify them, then plug them into the point slope formula. Plug these into the point slope formula. Step 3, solve and get y by itself. This is what you're going to do for this situation. Alrighty. All right, so let's do it. We're going to follow those steps to the T.
That says define x1 or x comma.
Identify x1, y1, and m. I didn't put a comma in between. Okay, alrighty. All right, so in this particular problem that you see on the board, did they give you the point? So what's x1?
-4.
Okay, so my x1 is equal to a -4. What's y1?
6.
And what's m?
1/4.
All right, can I plug all of that into the equation?
Yes.
That's exactly what they did. So as you can see here is my y1, here is my m, and here is my x1. They plugged it in. So here, once they plug it in, I'm just gonna add a step or two here. Here is the step that you don't see. Do you notice that you don't see this step? There's the first step. What did I do to get to the second step? What changed? What happened?
You distributed the negative, no?
Because you had a negative.
I had a negative, a minus 4, which becomes a +4, so that's the second step that you don't see. Alrighty? Next step is going to be what?
Multiply, distribute.
Okay, I'm trying to make sure I said it right. Okay, so again, we changed it. So you do see that step up there. That's me not looking at it clearly. Alrighty, so next step was to distribute. I'm sorry, I thought I didn't put a step up there. That is up there. Alrighty, so we changed. Now we're gonna actually distribute 1/4 to everything inside the parentheses, which becomes what? 1/4 x plus, I've got a 1/4 times 4. That step is not there. Alrighty? How do I do the math for a fraction times a whole number? I can put a 1 underneath this, right here. So now you have two fractions, and now you can multiply across the top and across the bottom. So when I do that, I end up with 1/4 x plus, okay, 1 times 4 is 4, and 4 times 1 is 4. What's 4 divided by 4? 1, alrighty. So now I've got 1/4 x plus 1. Do I have y by itself yet?
No.
What should I do to both sides?
And 6.
Add 6 to this side, add 6 to that side. So my final equation, y equals 1/4 x plus 7. Now is it in y equals mx plus b form? Yes, that is your goal every single time. This was type 1. Situation for type 1, you're going to be given a point and a slope. Type 2, you will be given at least 2 points. Okay? Let me bring this back down. Your type 2 situation, you will be given at least 2 points. You're given at least 2 points. Okay? So, what are your steps going to be? You have to calculate the slope, M, identify x1, y1, and then, of course, plug these in. Plug into void slope formula. And then, of course, solve for y. Alrighty. Solve for y, that's what they should say. Alrighty, so let's look at the next slide because it's going to take you back into real life before you end up with the details of the type 2 situation. Given at least, I didn't say at least what? Given at least 2 points. Alright. Alrighty, so here is the next slide. The next slide relates this back to real life again. So let's see if, make sure you understand the conversation. Do you have some points at the bottom of the screen? Do you have an XY table? Yes, those are some points. So we have at least 2. Now, I want to make sure we understand the conversation and what they're asking you to do. The table gives the number of drinks in the result and the resulting blood alcohol percent for a 180-pound man. Alrighty? 1 drink is equal to 1.25-ounce shot glass of an 80-proof liquor, or a 12-ounce can of regular beer, or a 5-ounce glass of table wine. Okay, in many states, they have set 0.08% as the legal limit for driving under the influence. Okay? Do you understand the conversation? If you have some drinks, you're going to get drunk. Okay? But how drunk are you going to be is the question. So, it gives you a table. It says if you have 3 drinks at a person that's 180 pounds, you're going to be at the 0.07% blood alcohol percent level. If you have 5 drinks, you at the 0.11. Look at 10 drinks, you 21% wasted. Okay, so now we want to see is the rate of change of the blood alcohol percent for a 180-pound person constant, or is it changing? Now, what am I asking you? How much is the blood alcohol percent going up for every drink you take? By how much? 0.02. So, does it go up 0.02 for every single drink you take? Yes. So, is the rate of change constant? Yes. So, the answer is yes, it's constant. It's staying the same. The rate of change is 0.02 for every additional drink that you take.
So constant function is where the rate of change is
It's saying, is the rate of change staying the same? Is it staying the same? Yes, the rate of change is only 0.02%. Okay, and what is it? 0.02%. So now, you just figure out what the rate of change is. What is the rate of change again? The same thing as the slope. And so then with that said, part B, what does part B say? It wants you to write the equation. I don't know what that is. It says write the equation of the function that models the blood alcohol percent as a function of the number of drinks. Do they want you to create an equation? Yes, they do. So, in order to have the equation, do we want the equation eventually to look like y equals mx plus b?
Yes.
Okay. Well, we know one part of it. What part do we know? Okay. You know the slope, so we can plug that part in, but do I know any part of the b? Do I know the y-intercept?
Yes.
What's the y-intercept? What is it?
You can subtract 0.07.
Okay, so wait. So what I'm trying to make sure I understand what you're saying. Can you tell me the actual y-intercept just from the data? No. Can we figure it out? Yes. But do we know it from the data? No, we don't. So the question becomes, do we use the point slope formula? Can we? Yes, we can. So again, the point slope formula says, let's do this. I got two ways I can show you guys how to do this. It just depends on which one feels more comfortable for you. So I can follow these steps and plug in what I know. Do I know the slope?
Yes.
Yes. Now, if you didn't know the slope, how would you have calculated? Because my number one says calculate the slope. Could you have calculated the slope? Do you have some x1s and y1s? X2, y2? Yeah, you could have calculated the slope. We could have done this. Okay, so could I pick any 2 points?
Yes.
Pick which one you want. So if I pick the first two, I'm going to do the first two. So I've got 0.0. I could do it this way. I'm just picking 2 points. Minus 0.09 over 3 minus 4. All right, well, what's that going to be? Negative 0.02 over negative 1. Well, negative divided by negative is a positive. So again, we figured this out already. Y'all said every time you took a drink, you went up 0.02%. So we know that's the slope. So I got that part. I got it down here. But I don't know B for this one, so I can't finish it with this yet. All right, so let's go ahead and use this formula. So I know 0.02 times x. Now, I need an x1 and a y1. Does it matter which pair? Don't matter. So I'll just pick 3 and 0.07. All righty, can I distribute? All righty. So here I'm just going to go ahead and distribute that 0.02 x, and 0.02 times 3 is 0.0, is that 0.6? Y'all check my math. All right, I've got y minus 0.07. Add what to both sides? Add 0.07 to both sides. I end up with y is equal to 0.02x. What's 0.06? That's a minus. Y'all check my math. Is that right? Negative 0.06 plus 0.07? Okay. That's the equation for that data.
Oh, you said it. At least, never mind.
Okay, all I did was pick 1 point, and you all helped me calculate the slope. Okay? So, if given at least 2 points, can you figure the equation out? Yes. Follow the steps. We okay? All right, let me give you an alternate way to do this. This is not required. Neither you get to choose which method. Sometimes I don't like giving multiple methods because then you get confused like, oh, no, she gave us a different method. All right, so I'm going to put it underneath the board so you don't have to use it. So if I have y equals mx plus b, and you know the slope, which we said was? All righty. I gotta have some more numbers to plug in to figure out what are we trying to figure out? B. Do you need to know what y and x are to write it in y equals mx plus b? No, you just need m and b. So I need to figure out what b is. So guess what? I'm gonna take one of them points from the xy table and plug it into this one. Okay, so now I'm gonna pick the same point I already had. So I'm gonna pick 3. And over here is gonna be 0.07. 0.02. Now can I solve and get b by itself?
Yes.
All right, so that's going to be 0.02 times 3 was 0.06. I need to get b by itself.
Subtract 0.06.
Subtract 0.06 from both sides.
Oh, that's easy.
Now you know what b is. You already know what m was.
So if we do it like that, we're going to...
Both ways are perfectly legal. Perfectly is whatever makes you happy. I will always say this to you. Do whichever method makes you happy. So this is y equals 0.02 plus x, x plus 0.01. This works every single time as well. It's your choice for what method you like best. Some of you may have learned it this way before or have seen it this way. Whichever way makes you happy. They both work. Okay. Alrighty, with that said, we've already discussed the details because you already said, his blood alcohol went up 0.02% for every drink that he took. We solved the equation, solved and got y by itself. We ended up with the same equation that's on the screen. Y equals 0.02x plus 0.01. Alrighty, so questions about the previous slide?
You said there's 3 types?
Yes, we have not done the third type. So first type, you're given a point and a slope. Second type, you're given at least 2 points. The third type, you're going to be given a point and an equation. We haven't gotten to it yet, but that's what's coming. Alrighty? This one says write an equation of a line that passes through how many points? Did they give you 2 points? So is this type 1 or type 2? Type 2. You only got 2 points. Which method you want to use? This one or this one? Whichever one make you happy. That's what you should do, whichever one makes you happy. Now, again, on the slide, they used the one with the point slope formula. That's what's being done. So on the slide, which you see, they went ahead and did, what was the first step that we had to do? You got to calculate the slope first, regardless. So you got to go calculate the slope, which they did, and they ended up with 2/3. We plug the slope in right here, and we pick the point as x1, y1. So notice, here is x1, here's y1, and we plug them in here. x1 goes here, y1 goes here. Now again, whichever one makes you happy. Now, question, can you tell how we got from here to here?
Yes, multiply. Multiply the slope.
Okay, well, let me put a step in, just in case. Let me put an extra step here. But just to make sure you're okay with all the steps, let me put a step in here. So this is going to be x plus 2. All right, you see where the negative 2 became a positive 2. All right, then you have to distribute
2/3.
2/3 to everything inside the parentheses, which gives me 2/3x plus 2/3 times 2. Can I put a 1 underneath here?
Yes.
Okay, so we end up with 2/3 x plus what? 4 over 3. That's how they got to that step. Now, what do? Because we don't have y by itself.
Try to
Add
add 3.
3 to this side and add 3 over here to this side. Now, it assumes that we remember how to add fractions and whole numbers. So here is, over on your scratch paper, adding fraction plus a whole number. Put a 1 underneath it. So when you have a fraction and a whole number, put a 1 underneath the number, that's the whole number, so you can turn it into a fraction. Now, you need to find the least common denominator, which happens to be 3. So all both denominators have to become 3. What do I multiply this 1 by for it to become a 3?
3.
And what you do on the bottom, you always have to do on the top. So find the least common denominator. Make sure both bottoms happen to be the same, whatever that denominator is. Multiply whatever you got to multiply this bottom by so that becomes a 3. And then do the same thing on top. So now I have 4/3 plus what? 9 over
3.
Okay, 4 plus 3 is 13. So once you have like denominators, you keep the denominator the same and add the numerators, which are the top numbers, together. So over here, in this space right here, is end up being 13 over 3. There's your equation. Would I have gotten the same thing doing it this method? Yes. Would you still end up having to add fractions? Yes. And whole numbers? Yes. Question? Alrighty, all right, question here. All right, back to real life again. All right, let's see what we're given and let's see what it's asking us to do. See if we can figure this out. All right, the number of people in millions in the U.S. prisons or jails grew at a constant rate from 2001 to 2013, with 1.345 million people incarcerated in 2011 and 1.570 million incarcerated in 2013. What is the rate of growth of people incarcerated from 2001 to 2013? The rate of growth and rate of change are the same thing. Okay? They want to know what's the rate of increase of people in prison. What's the rate of increase? What should we do? If we looking for the slope, right? Yes. Do you have enough information to do the slope calculation? Yes. Yes. Okay. So the question is, I want to know what's the growth rate per year. So here we go with in 2011, it was how many? 1.570 in 2011.
And they put 2001.
And then, wait, let me make sure I read it right. Did I read it right? Okay, so there's a typo somewhere there.
2011, 2001.
Okay. Does the math come out right when you do that on the calculator? Somebody do that on the calculator for this. Does this math come out right? Because I agree, one of these is wrong. It's either 2001 is wrong or 2011 is wrong. Check this on the calculator. Does this come out right on the calculator when you put it in? Okay, change this right here to 2011, or let me see if I'm doing this right. Change it to 2011 on the bottom over here. From 2013, it should be 2013 minus 2011, and then tell me what this turns out to be. Trying to see if let me use my calculator as well. Yes.
Oh, it does hurt. No, right, no, it doesn't.
Which one is right, y'all?
It's not right.
Okay, hold on. Let me put it in my
Okay, I
calculator.
got a question. So what you got right there on those slides, it's not in this book? Are the numbers different or what?
When you say it's not in the book, do you mean that you didn't see the example exactly like what's in the book?
It's like the one in the book is an MA population,
It's gonna be
but the numbers are different.
Oh, it's okay. That's okay. Because again, what we pull as professor slides could look slightly different from what we pull here, but the conversation should be similar.
Yeah, it is.
Okay. So let me see which one. Oh, guys, let me just see what's off with my slide here. Which one worked, guys? Did y'all figure it out?
No, you can subtract 2011 again. I got .0187.
When you did what?
When I subtracted
Just like it is?
yeah.
Okay.
I got .01.
All right, hold on, y'all. I'm gonna type it in myself. I'm gonna type. Hold on. Let me go to my calculator on screen so you can see it for yourself. All right, here is the calculator that I use on screen that you guys can have. It's called web2.0calc.com, and it's just you don't have to download anything. You just type whatever you want to type in here. All right, somebody read that. Read that to me. 1.570 minus 1.345 divided by 2013. Okay, I gotta retype this right because it's not. You see, it's not right, correct? So I have to put this in parentheses so it knows to do it like I want it. Okay, and then I have to put this in parentheses because this one doesn't have a fraction button. Alrighty, that's what I wanted, right?
Yeah.
Okay, hit the equal sign. Okay, is that the same thing we got?
Yeah.
Okay, 01875.
It's not.
Hold on. Hold on. Okay, this looks like there's a typo here. All right, what else do we get when we plug in a 2011? I'm just curious to see what's different. Hold on. All righty, so let me change it. Hold on, let me change it real quick. And I want to see if that's closer. That will tell me which one is my mistake. Enter. Oh, that ain't not even close. Okay, so it's supposed to be 2001, and there's a typo in the slide.
Switch the 1 and the 0.
Yeah, all right, so if I go back to the slide. So here, this should be 20, no, not that one. This
It's
one.
the answer part.
Yep, that should be 01.
And the answer's the truth.
And this answer down here, the 0 should not be here, correct?
It's just 0, 1.
Switch with the 1.
With the one.
Oh, put the 0 up here. 0875. Hold
0,
on.
1, 8, 7.
Okay, all right. All right, so just kind of know that that slide needs to be changed, because when I try to change it in here, it won't let me change it here. I'll fix it later, guys. I'll just make a note for myself to fix that slide. So that's gonna be 0.01875. All right, this is slide number 11. All right, I'll fix that. All righty, so otherwise, guys, when you do this, do you see what numbers you're given? Can you see that you're given the incarceration for 1 year and the incarceration for a different year? And so you subtract those two numbers, because those are your Y1, your Y2, and you've got your X1, your X2, which are your years. What are you thinking?
I wonder how come this time we don't have to like convert the years?
Because it didn't say. It doesn't say X is the number of years after. So if it don't say that, you don't have to convert it. Most cases, it will say that. X is the number of years after or whatever. So because it doesn't say it, we're going to use the exact years that they gave us. Okay? So what's the slope?
0.01875.
Okay, note that's got to be changed. And is that increasing or decreasing? Is that slope positive or negative? Positive. So the increase, is it going to be increasing? The prison population is increasing based upon what you see here. All right, questions. So homework assignment will be similar. All righty, what else, guys? What else about that one? Could you do that one yourself? Yes, okay. All right. So when I look at your faces, I'm looking to see if you're like, yeah, I can. I ain't sure yet. Let me think about it. I need to process it some more. So again, would you be comfortable doing this by yourself if you had to do that one by yourself? And the reason I'm asked, question, did you realize rate of growth and rate of change and slope were the same thing? Did you know that part? Yes? Okay. Did you see that there were 4 numbers in the conversation? Your one was an X1, Y1, one was an X2, Y2. When there are 4 numbers in the conversation and they asked you for the rate of growth, rate of change, slope, marginal profit, marginal loss, you are doing the slope formula. Now, question, did you know what numbers to put on top and what numbers to put on the bottom? Once you had to figure out which was which. Years or time, minutes, seconds, hours, months, years, always is going to be your input values or your X values. And in the slope formula, X values or input values always go on the bottom. You see? So that's why your 2013 and your 2001 went on the bottom. Years usually always go on the bottom. Okay, question. All right, here are our next slide. All right, let's see again. It asks us to write the equation. And what did we just do? Which part did we just do? We just did the slope. All right, so we didn't finish it yet, guys. We just did the slope. And notice it's typed right in this one. Did y'all notice that I typed it right in that one? Yeah. Okay, all righty, so we're good. All right, so let me finish it, make sure we're okay. We know the slope, so the question becomes, we got to figure out if we can write the equation in y equals mx plus b form using, are we going to use this method, guys, or are we going to use this method? Y'all, do y'all like the bottom one?
Yes.
Okay, y'all like the bottom. I heard that. All right, so using that method, let me go ahead and do it using it just so you can see it. All right, let's erase this one. I still got to do what? Now, let's see what it says up here. Does it give us any additional information to change? You write the linear equation that models the number in a person as a function of the year. Say it again.
It says incarcerated in 2011. So she was saying I shouldn't be right there.
Oh. To 2001. Okay. All righty. Got it. All righty. So we're good? All righty. So with that said, let me go ahead and use this formula that you see up on the board. Y equals mx plus b. What's the slope?
0.01875.
Okay, 0.01875. X plus b equals y. What numbers do you want me to plug in? Do I have x1 and a y1? Yeah, which one you want me to plug in?
2013.
This one they picked 2013. What was the incarceration rate in 2013?
1.57.
Okay, so all right, I'm just gonna take and put in the place of the y, I'm gonna put how much? How many people? What was the rate?
1.57.
1.570, okay? And over here, what do we do?
Plus B.
Plus B? What am I missing?
Whoa.
What am I missing that I didn't put in? What year was that? In 2013. All right, so there we go, plus B. All righty, so I plugged in for 2013, there was 1.57 million incarcerated. Now I'm just gonna solve and get B by itself. All righty, somebody use a calculator, tell me what this is right here. 0.01875 times 2013 is how much?
37.
I'm listening, go ahead.
37.7437.
37 point what?
743375.
743375.
74375. 13.
13. All righty. Do what to both sides?
Subtract 1.570.
Subtract 1.570 from both sides?
Yes.
Oh. What are we trying to get by itself? Trying to get B by itself. All right, somebody do that on the calculator. Tell me what this turns out to be. All right, we subtracted that from both sides, so B equals what? Negative what?
Negative 36.17375.
So now can I write the equation y equals mx plus b? Yeah, so here's my equation. We figured out what b was. We knew what the slope was. So I've got 0.01875x minus 36.1735. This is the equation for what?
17375.
17375, okay. Thank you. Did I put it down there right as well? 17375. Alrighty. So what was the goal? We needed our equation for that situation, for that conversation. You were given a year and an incarceration and a number of people in prison and given a second year. And they wanted to know, can you create an equation that'll model that information? And we said, yes. And we said, hey, we're going to do it this way using the y equals mx plus b method. Plug in one of the years and the incarceration for that year, because we calculated the slope already. Solve to get b by itself, so I can figure out what my b value was that needed to go into y equals mx plus b equation, and we're done. Totally up to you guys whether you want to use the point slope formula or your y equals mx plus b formula. Question. Now, instead of y equals mx plus b, what do they have it written as? And so I will say this to you very carefully. Make sure when you go to type this in my math lab, you put the right letter, because if you put y, they're going to mark it wrong, even though I know it's right. I'm just saying, make sure you keep up with what letters they use, because if they use N, you got to use N. All right, so there we go. It's just explaining what we already talked about. Now let's see what the next question. It asks us to do something else. Use the function. When it says use the function, that means the equation that you just created. Use the function to predict the inmate population in 2017. So what do I do? Plug in 2017 into that equation that we just created, and we find out what? 1.645 million were incarcerated in 2017.
So this time you gotta use the point slope.
No. They plugged it back into this one. They plugged it into this one. They put 2017 into the new equation that you got. So when it says use the function or use the model that was created, they mean use the one you just created and plug in 2017. Questions? All right. Does this make sense, guys? We're still using real world situations to show you how you can use y equals mx plus b. And how the equations get created. Now, what you will learn is when we get to the quadratic equations and other ones, you won't have to create it by hand. That's when we're going to use the tool that creates the equation for you. All righty, so with that said, let's talk about horizontal and vertical lines. Did I show you the horizontal and vertical lines? Yes. How do you create a horizontal line? How do you create the equation for a horizontal line? Here's my, hold on, here's my x-axis, my y-axis. 1, 2, 3, 4. and I'm gonna create, there's my horizontal line. What's the equation? Thank you. All right, here's a different one. 1, 2, 3, 4, 5, 6, 7. Here's my vertical line. What's the equation? Done. So we don't even talk about that slide right there. So y'all are good. Always know that you can write every vertical line as x equals a number and every horizontal line is y equals that number. Alrighty? Okay, so let me see if this is a different one or the same situation. Write an equation for the lines that pass through the point -1, 5 and have a slope of 0. This is not supposed to be a tricky one. Okay, so part A, the slope is 0. What's the equation of the line? So what kind of line is it? Okay, so where is that point at? What? Now wait. There's a point. -1, 5. Where is -1, 5 at? Hold on. All right, -1, 5.
Down 1 and over 5.
Okay,
To the left.
is it down 1 and over 5 or over 1?
Over 1 and down 5.
Okay, over 1 and what? Okay, over 1, right here, and up 5. 1, 2, 3, 4, 5. All right, put my point right there. And what kind of line did you say? Horizontal. Oh, how do you know it's horizontal? Because slope is 0. Okay, I agree with you. All right, there's my line. What's the equation? Y equals 5. So, again, when it's a horizontal line, whatever the y value is the equation. Y is what? So is y equals 5. Done. Don't be trying to overthink it. Okay? If you have a slope of 0, it's a horizontal line, y is 5. Y equals 5 is the answer. That's the equation. That's it. Now, here's the second one. It says it wants it as an undefined slope. What does that mean if the slope is undefined? It's a vertical line. All righty. So erase this right here and now create a vertical line. Now, what's the equation of that line? X equals what? -1. So whatever your x value is the answer. X equals -1. Done. So that's x equals -1 is your equation.
When I do my homework, I forget how easy this is.
Yeah, that's what I'm saying. Don't get deep with it now. It's just that simple. If they give you a point and tell you it's a vertical line, it's x equal whatever x is. If they give you the point and it's a horizontal line, y is whatever y is. Done. You like, it can't be that easy. Yes, it can. Yes, it can. So again, you're okay? You practice it though, guys. Practice it. I'm just saying practice it because I do understand that sometimes when you see it the first time, you're like, yeah, you make it so easy. Now I get home and I just like, what? All right, so there we go with that one. All righty, here is the third type. Remember I said when it comes to creating equations, linear equations, you've got 3 types. What was type 1?
A point and a slope.
You're going to be given a point and a slope, and you have to create the equation. What's the second type? I'll give you at least 2 points, and you've got to create the slope. Excuse me, you got to create you have to calculate the slope, but you got to create the equation. You first have to calculate your slope, and then use either point slope or the y equals mx plus b. Here's the third type. You're going to be given a point and an equation. Third type, you're going to be given a point and an equation. And they want you to find a different equation. In this particular case, they want you to find one that is parallel. So third type, given a point and an equation, and they want you to find a different equation. All right, so with that said, let's do the math. All right, so you want your final equation to look like y equals mx plus b, right? All right, you need what 2 things to make this equation? Slope and the y-intercept, okay? You gotta have those two things. All right, so I want to figure out what is first. What am I gonna need first? Okay, need the slope. So you're gonna need your slope. Number one, need the slope. Can you figure out what the slope is? They didn't give you they only gave you 1 point. So can you calculate the slope with 1 point? No. So they need you to figure out the slope of the equation that they gave you.
So basically, you gotta plug in.
You need the slope. So you gotta rewrite that equation in y equals mx plus b form. So rewrite, here's the step. You rewrite equation in y equals mx plus b form. Mx plus b form. Alrighty, so here we go. That equation is 5x minus 2y equals 8. What should I do first? Okay, subtract 5x from both sides. I end up with negative 2y equals negative 5x plus 8. Divide both sides by? Alrighty, so y is equal to,
Positive 5/2.
because you got a negative divided by a negative, it's going to be a positive 5/2x. 8 divided by negative 2 is?
-4, -4.
Okay, I agree with you. So there is your equation of the same line they already gave you. So they gave you the equation, and there's the equation written in y equals mx plus b form. Now here's the key with this one. You're looking for the equation of a parallel line to that line. Now, parallel lines, look at them. Here are two parallel lines. What you know about parallel lines?
They have the same slope.
They have the same slope. So, do I need a new slope now? No, I can keep the same slope. So far, I know m is equal to what? 5/2. Now I need what? What I need, are we trying to get this equation to look like this? Yes. So what do I need now? The y-intercept, which is my b. All right. Do y'all want me to use the same equation again? Okay. All right. So now you know the slope. So here I've got y is equal to mx plus b. I'm going to plug in 5/2 as my slope. Do I know an x and a y? Did they give me a point?
Yes.
They did. So can I just plug that point in? Yes. All right. So I've got 5/2. What am I plugging in for x? -2. All righty. What am I plugging in for y? All right. Now just solve and get b by itself. All righty. So with this said, I've got fraction and a whole number. For multiplication of fraction, you can change this. If you already know what it is and you don't need to do this extra step, you can change this so that you put a 1 underneath here. So again, this is still times. This is 5 times. I can write it this way. Do you know how to do crisscross cancel? If you have a number on the top and a number on the bottom, you can cancel them out. That's one way to do that, if you remember how to do it. All right, so I'm going to go ahead and multiply straight across the top and straight across the bottom. 5 times -2 is? -10/2. Can I simplify -10/2? -5, okay. And -5 plus b, and I've got 3 over here. Add what to both sides? Add 5 to both sides. And you end up with b equals 8. So now what's my equation of the parallel line? Of the other parallel line? Equals
5/2x plus 8.
done. All right, when are you going to do this? When it gives you a what, it's going to give you a point and ask you to find a parallel line. It's going to ask you to find the equation of a parallel line. Yes.
Where did the 3 come from?
The 3 was, we pulled it from the E. The point, see the point says -2, 3.
Okay.
So they gave you an X and a Y. So we just plug in X and Y. So here, if I put in a plug in x comma y, or in this case, negative 3 comma 2. All right, and here we plugged in the slope. All righty, questions? All right, what questions do you have?
It works the same way when it's going perpendicular.
Almost, slight difference, but a good question. All righty, so this was when we needed to find what kind of equation? You needed a parallel equation. What happens when they ask you to find the perpendicular equation?
You need a reciprocal.
You need a reciprocal. When it's a reciprocal of what? Of the slope. If they ask you for a perpendicular line, you can't leave the slope the same. You have to flip it upside down and change the sign. So we call that the inverse reciprocal. So if they ask you for a perpendicular, flip this upside down and change the sign. Everything else is the same. If they ask you for a perpendicular line, you flip the slope upside down and change the sign. So instead of positive 5 over 2, it's going to be a negative 2 over 5. When do you do that? Only if it asks you for a perpendicular line. So here is the one with the perpendicular one. So let's work that one out so you can see it. And then, let me see, and then we'll stop. Let's work that one out so you can see it. Alrighty, what changed? Nothing but the slope. So for the perpendicular line, again, we're doing perpendicular line here. My slope is equal to negative 2 over 5. So I'm going to plug in the same 2 points, but my slope is now going to be negative 2 over 5. So over here, I'm going to have y is equal to negative 2 over 5 x plus b. Plug in your points. What points we got? Same points. We're going to plug in the same point. So we got a 3, negative 2 over 5, and then this was a negative 2 got plugged in, right? Yes. And that was a 3 here. Plus b. Alrighty? I got a fraction and a whole number. Put a 1 underneath it. So you end up with what? 4 over 5 plus b equals 3. Subtract 4/5 from both sides. Subtract 4 over 5 from both sides. So now you got subtraction math with a whole number and a fraction. So b is going to be equal to whatever we get when we do that fraction math. Say it again. I'm going to go ahead and do it so I can see it, so I can make sure everybody's on the same page. So I've got 3 minus 4 over 5. Let's erase this because I can use the other space here. All right, so just bringing this over here. So I've got 3 minus 4 over 5. Put a 1 underneath it. What's my common denominator? 5. So I need this to be a 5. What do I multiply 1 by to get a 5? Okay. Do what you do on the bottom. You got to do it on the top. So now I have 15 over 5 minus 4 over 5, which is 11 over 5. So now what's my new perpendicular equation? Here's your perpendicular equation. What is it?
Y equals negative 2 over 5x.
Negative.
11 over 5.
Plus, as your perpendicular equation. Say it again. 11 over 5. Thank you. And let's erase this because that part. All righty. What changed between parallel and perpendicular?
You flip it and change it.
Okay, slope gets flipped upside down and change the sign. Alrighty, that's enough for today. We'll finish 1.4 when you come back, and we'll also do 2.1. I will tell you when the test is on Thursday when we come back in here. I will specifically tell you when the test is. I do have a question for you guys, and I kind of want you just to send me an email just to kind of tell me what you think about it. I am considering doing a test, online test. I'm just considering it. I'm just trying to figure out if that's a good idea or not a good idea, just because I want to have class time to do all the work that we need to get done and not take a day for tests. That's what I'm trying to do. So I'm working on that now, but I would like I'd like some of your feedback for doing an online test, because other professors are doing it as well, and I'm curious to see what your thoughts are about having an online test. And there would also be some particulars that I would have to, parameters I would have to set with it as well.
What did it have to do with lockdown?
That's what I gotta figure that part out.
Because if we do that, then that would kind of hurt us using, desmos, wouldn't it?
That's the key. The key is that I would make it so that you still would have access to desmos. So that would be the big thing. If you missed a homework or quiz, I will open everything up the last week of class. So that way, if you go back to it, remember I'm dropping 2 quizzes and 2 homeworks.